Hey everybody, welcome back for some more solving inequalities practice. When you are solving and graphing inequalities, you want to make sure to follow the same steps that you would for solving equations. So we'll look at some that are a little bit tricky today. We got a little bit of that last lesson. But basically, before you graph, you have to get the variable by itself. Now, there's one special rule that you have to remember when you're dealing with inequalities. If you multiply or divide both sides by a negative number, you need to switch the inequality sign. All right. So only if you multiply or divide both sides by a negative number, you switch the inequality sign. So let's take a look. So the first one, it's not ready to graph yet. We have to solve for x. Draw the line down just like you would under an equal sign. All right, I see a plus 2, so I'm going to subtract 2. And by the way, if at any point you want to try these on your own and then check to see if you got it right, not a bad idea. That's what we would be doing if we were in class. All right, I notice, don't change this to an equal sign. We're so used to working with equations, a lot of times we change it to an equal sign. All right, divide both sides by 5, so all of my x's are less than or equal to 3. So it's solved. And now it's not just one answer. It could be 3 or anything less than 3. So we're going to show the solution on the graph. So we have a closed circle at 3 because it could equal 3. Then you want to shade the numbers that are less than 3. So anything in there, all the way to negative infinity. Oops. Hope if I made that right. All right. If your x is on the other side, not a big deal. All right, your goal is still the same. You want to get the x by itself, so we're going to just get rid of anything else. I see a 3, so I'm going to subtract it over, and I'm left with 18 is less than or equal to positive 9x. Now, if you don't like it like that, you can switch sides. The only thing is, when you switch an equation, it's fine, but if you're switching an inequality, if 18 is less than 9x, then if you switch it, 9x would be greater than or equal to 18. So if you switch sides, you need to switch the sign. Or you can just continue. All right, I'll divide both sides by 9. I'm left with 2 is less than or equal to x. But again, be careful there. It might help if you switch sides. If 2 is less than x, then x is greater than or equal to 2. Either way, you're going to have a closed circle at 2. And then think about the numbers that are going to make that true. 2 is less than what? 2 is less than 3. 2 is less than 4. 2 is less than 5. All right, you're going to shade that way. If the x is on the left-hand side of the equation, or inequality, think of this as an arrow pointing in the direction you're going to shade. But if x is on the right, that's pointing in the opposite direction. All right, if you went this way with it, if you switched them right off the bat, you'd end up with the same thing. Oops. What am I doing over there? Okay, 2. X, either way, x is greater than or equal to 2. Haven't seen that sign yet, but it's coming up now. So again, we need to get x by itself. Now, I want you to notice that there's a negative in front of the x. So that 9 is actually positive. We're going to subtract it to be with the 10. And notice how I'm circling the x's. Sometimes it makes it easier to figure out what's going to move. All right, so negative x is greater than 1. Now, that's the same as negative 1 times x. So I'm going to divide both sides by negative 1. And here's that rule. All right, if you divide both sides by a negative, it's not going to be greater than anymore. It's now less than. And 1 divided by negative 1 is negative 1. So notice that changed. All right. So if you multiply or divide both sides by a negative, you're going to change the sign. Okay. So next one, again, if you don't like it like this, switch sides. So it'll be 7x plus 6. Since 27 is less than that, this is greater than 27, and you could solve from there. But either way, I'm going to subtract 6. So I have 21 is less than or equal to 7x. Divide by 7. So I have 3 is less than or equal to x. Or if I switch it, x is greater than or equal to 3. All right, so we have a closed circle. Oh, I just realized I didn't graph the other one. We want to shade the numbers that are going to make this true. All our x's are bigger than 3. Shade towards the larger side, the larger numbers to the right. Over here, x is less than -1, so it's just an open circle at -1. Remember, that's your boundary. And then anything that's less than -1 is going to actually be this way. All those numbers are less than -1. Less than to the left. All right, on the second page, we got some that are a little bit more complicated, but that's okay. I have faith in you. All right, I see parentheses. So let's think about that. We want to distribute first. Going back to chapter 1. So it's 3x minus 6 is greater than or equal to 2x plus 1. Next, we want to combine our like terms. All right, so I'm going to just circle them. All right, now I notice the 2x and 3x are on opposite sides, so I like every time to bring the variables to the left. I think it makes it easier in the long run with inequalities, but it's entirely up to you. Since 2x needs to cross over, remember things are opposite. It's like a mirror, so if it's positive, we're going to subtract. So we're left with 1x minus 6 is greater than or equal to 1. Now I have to add 6 to get rid of that minus 6. So 1x, or just x, is greater than or equal to 7, and you're done. So on a number line, 7 would go in the middle. Zoom in, 6, 7, 8. It's an closed circle because it's greater than or equal to 7, so 7 is a solution. And shade the numbers that are bigger than 7. We're going to go that way. Just shade in that arrow too. All right. Again, be careful with this negative, how it's written. We're so used to moving that second term, but that has an x. We want to get the 8 out of there. So I'm going to subtract the 8. Negative 2x is greater than 8. Divide by -2 on both sides. Oh, there's that rule again. If you divide both sides by a negative, it's not going to be greater than anymore now. It's less than. Change that sign. 8 divided by -2, -4. So when I go to graph it, -4. Now be careful, you're in the negatives. 0 is this way. -1, -1, -2, -3, -4, -5 is this way. Watch out in the negatives. Things are a little backwards. All right, open circle at -4, and we're going to shade the numbers that are less than to the left. All right, and the last one, wow, what a doozy. Well, just remember, we're going to simplify each side first. We're going to take care of parentheses. Then we'll combine like terms that are on the same side before we move anything around. All right, you can do this one. Don't look at it and say, yeah, no, I'm not doing it. Pause the video, give it a try, or even the first step. All right, so I see parentheses. We're going to deal with that first. So we have 8x minus 16. Now be careful right here. It's -3 times 2x. So -6x, and -3 times 1 would be -3. Watch your signs there. Is less than or equal to 7x plus 4, and there's that -3 again. -3 times x is -3x. -3 times 1 is -3. All right, so we've taken care of our parentheses. Now what can you combine on the same side? Circle those x's. All right, so I have 8x minus 6x is 2x. They're on the same side. You don't change their sign. -16 minus 3, if you're not sure, type it into the calculator. -19. Over here, 7x minus 3x. Again, you just combine them as is. You don't change its sign. And then 4 minus 3 is +1. Wow, look how far we've come already. All right, now we're going to circle our like terms. Now I know a lot of you like to move the smaller one to be with the larger, but with the inequalities, I think it's less confusing if you have all your variables on the left. So I'm actually going to subtract my 4x over. So I'm left with negative 2x minus 19 is less than or equal to positive 1. Add 19 to get rid of the minus 19. Negative 2x is less than or equal to 20. And then lastly, we're dividing by negative 2, and oh, there's that rule again. So since I'm dividing both sides by a negative, it's now going to be greater than or equal to negative 10. Each step individually isn't so bad. Just take your time with it. All right, again, negative 10's in the middle. Negative 11 is this way. The further you get away from 0, negative 9's this way. We're going to have a closed circle on negative 10. And we're going to shade the numbers that are greater than, and think of that as an arrow pointing in that direction. You can use that to help you if x is on the left. All right, so you've got some practice tonight on page 6. So there's 4 examples to solve and graph, and then write an inequality to match each graph. If you need to, take a look at the first lesson. Have a great day, and don't forget, stop by Math Lab if you have questions.